questions from 5 problem sheet, or similar problem not from the problem sheets.
Okay, sir.
You have to answer any 3, 45 minutes.
And sir, one problem will means each question will be from one chapter only. Like, will
Yes,
there be
yes, yes.
mixed? Okay, okay, sir.
Yes, only one chapter. One chapter, one question only. That is perfect. That is true. Okay.
Sir, is this chapter
Okay, sir.
frames in
Thank you.
midsem syllabus?
For mid-sem, problem sheet 1, 2, 3.1, 3.2, 3.3. Sorry, 3.1, 3.2. Then 4. Frame is 4. And for distributed forces, that is 5.1, 5.2, 5.3. Up to 5.3, it will be midterm syllabus. Whatever I have given to you, that is for midterm syllabus. Okay.
Okay, sir.
Okay. So actually, moment of inertia 6.1, 6.2, 6.3. That is also from the static, but due to less time, we are not able to cover for your midterm exam. So that will be end semester examinations. Okay. Plus
Sir,
the
are we allowed
dynamics you
to,
have to start. Yes.
sir,
Tell me. Yeah.
are we allowed to use whitener বা white pen for
No, 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 no. You just strike it out. No problem. Okay. Don't worry. You strike it out. That is enough. Don't use
and sir,
any whitener
every
or
every image should be drawn in pencil.
which one?
Means sir, any image in the
Uh,
problem when you
mm.
solve the problem, it should be drawn in pencil.
No, no, not required. It is not mandatory. If you want, you can give, but make sure after the scan it is visible to me.
Yes, sir, that's the problem. If you draw in pencil, it is very hard to make it visible after clicking photo.
So what we can do initially, maybe you can draw in pencil, then you can yeah, the faint thin marking using pencil. Then you can use pen, or directly we can use pen. No issue.
Oh, okay, sir.
We
Okay,
have no
sir.
issue. As per this subject is concerned, no issue at all. If students are writing in pen only, no issue. Somebody can use multiple color pen also, but don't use red one. Okay.
Okay, sir. Thank you.
Say if you are say comfortable with some say black pen, some blue, some other apart from the red one, it is okay. Then we'll understand that it is very easy for you also. You can do that. Multiple color you can use except red color. Hmm. Okay. Any other questions?
So, in
Yeah.
the problems of forces and equilibrium, there are at a time 3 equations. So, do we have to show the calculation of the equations, or we will solve it in rough and then directly put the values?
Okay. The answer is there should not be any step jump. There should not be any step jump in your solutions. So each and every step you have to show in your answer script. Rough page you can do whatever you want, but I would like to check that you have 3 equations, you solve everything, and that is been represented in the answer script. No step jump. Okay, you cannot do that way. Then what I not only me, any of the examiner will assume that you are doing something. How you are 3 equations, you are not showing anything solutions, step jump directly solution, then your that will act as the adverse effect. So even if you say you have 3 equations, you can write that by solving this 3 equation, you can identify the 3 unknowns. That is acceptable with part marks. But if you write from equation 1, 2, and 3, you can get ax equal to that kilonewton, ay equal to that kilonewton. Then your entire exercise will be as a result it will be 0. I will not give any marks because I will assume something else. Understood?
वो साला सियाना है इसका
Hmm? Hello? Are you telling something? See, if you are using some sound, I can hear it, okay? Then ultimately you will be loser. Nothing will happen for me. Don't use that type of language, okay? It is not your school days. Whatever habit you have, your school teachers, they are responsible for your this type of attitude, okay? So you deserve that. Your school deserve that. And I will try to make sure that in IIST that malpractice should not be there. Okay. Without delay, I can start last chapter, that is from distributed forces, and this corresponds to problem sheet 5.1, 5.2 and 5.3. So, and this is the statutory warning. Slides are prepared for classroom teaching purpose only. Don't share it to any of the online media. So, distributed forces. To start with this distributed forces, I should give little bit introductions or some sort of information to you. Say for example, when we are considering that this earth is exerting some gravitational forces on which the particle forming a on each of the particle which are basically forming a body, then these forces can be replaced by a single equivalent force equal to the weight of the body. And you know that we will apply this at the center of gravity of the body. Okay. So when we are talking about that any volume, we can calculate similar way centroid. For area also we can identify the centroid of the area. So and line also, for line also we can calculate centroid of the line. Okay, and we will use the concept of fast movement to calculate such centroid. So there are two things. One is centroid and center of gravity. Basically, the centroid is a function of area. Okay, actually it is a function of geometry, rather say, but center of gravity is not area. It is related to its weight of the body. Its weight of the body. Now, if I read out here from here that previous chapters, what we did, we have used all forces as some concentrated force acting or acting along their line of actions and at their point of applications. But this concentrated word is applicable for that. But in reality, it is not so. Every external force applied mechanically to a body is basically distributed over some finite contact area. However, it may be small. So the concentrated on a point, that is our assumptions. Reality, it is distributed. It is distributed over a finite contact area. Based on that concept, we'll calculate the centroid or center of gravity. Okay. Now, when, as I told, when it is centroid, it is a function of geometry. Centroid. It is geometry. Center of gravity related to the weight. Center of mass related to its mass distributions. Now, if I consider this type of things like centroid as it is related to geometry, so the geometry can be on a line. So I have one something line like this, and this is y equal to say fx, some form. Okay. So for line distributions, when you are applying the force or maybe we are calculating centroid, it is distributed along the line, then we can calculate based on the intensity of the loading. We can calculate that center of centroid or center of mass or center of gravity for that particular type of distributions. Sometimes distribution may be over the some area. We call area distributions. Sometimes the distribution may be over the volume. It's self weight. It is over the volume. We call volume distributions. We call the volume distributions. Say for examples, here there is one tire is connected to ground. Sorry, it is a tire connected to its ground, and basically initially maybe contact was point contact, not point contact. If you take the 3D view, it will be line contact basically, but there will be some deformation of the tire, and finally there will be some surface on which force will act as the reaction force from the ground. Okay, so here one sphere, one curve, one, then also after deformation, this is the distributions of the forces. Here also, when we have applied some concentrated force, here we have applied some concentrated force, we are showing there, but basically as a reactions, this will be the area of contact, and it will exert the reaction forces. Similar way, as I told, say I have one cable is having some its own weight, say for examples, and this is the distribution of the weight. Okay, and it is acting that something like we call the some Newton load per unit area, say Newton per millimeter line load. Here it is pressure, so based on the depth, pressure is increasing. Then maybe we have some sort of distribution force like this, and we can calculate using first moment principle centroid of that forces. Okay. Now, as I told, that when it is center of mass, we are talking about the mass of the body, on which locations it is acting. Say for examples, I have this body and it is suspended using string. Okay, so always it is having the tendency, if it is a weight, okay, if it is the weight, we did this type of exercise also. If we cut here, it will show this is the T and this is the weight, and it is acting vertical directions, line of action is same. So this is the location of the centroid. Now if we tilt little bit, if we tilt this way or this way, okay, but finally it will try to have some oscillations with respect to the centroid. With respect to the CG, center of gravity. Okay. Now, how we can calculate the center of gravity? We can do this using principle of moments. We can use, say for examples, this is the 3D body, 3-dimensional body, and I am considering one small element. We call small element or strip. Some small strip we can consider, its weight is dw, and say this is the CG, location of the center of gravity through which the W is supposed to work. Now if I have this small strip and its distance, say for example from x-axis, y-axis, z-axis are x, y and z. So this small from the small strip, we can, if we do the integrations, finally we can get the location of the centroid using the first principle. So how we used to do this? Say, if it is x bar is the x coordinate of the center of gravity multiplied by its own weight equal to integration of x dw. So what we did, small strip we have considered there, dw its weight, x is the distance, x distance as per the coordinate, and it's the total weight, and this is the location of the CG. Okay, so on the other hand, we can write this way, x bar summation x dw by w. Okay, Similar way, y bar, z bar. Now you consider that if it is center of gravity, we are using this. But if it is the area, center of mass, then what we supposed to write? This 1 prime equal to summation x dm. Here it is dm. If it is area, how we used to write? Double prime x dv by v. Sorry, if it is volume. If it is area, then x bar this equal to x dA by integration. Sorry, I can write this one. I missed it. It is better to write this way, dA. And if it is line, then this x say dx this. These are the, sorry, 1 bar is more. So basically this W is, here it is integration over dW. Okay. Now when we will ask that calculate center of gravity, you should start with this expression. If I ask center of mass, you have to start with this expression. Centroid of volume, use this expression. Centroid of area, use this expression. Centroid of line, use these expressions. Maybe that it is homogeneous body, so density is same everywhere, and it's solid body. In that case, maybe that center of gravity and center of mass is same. Okay. And it may be if you have that is true for solid structures. Okay. And density is same, and you can have the center of gravity and center of mass and center of centroid of the volume will be same. If you have constant thickness of the body, maybe that is same for the center of area, centroid of the area. If it is having constant cross sections of the 3D body, maybe it is centroid same as the centroid of the line. But whatever being asked, you have to be careful that you are using proper expression. Something may be numerator, denominator may be cancelled out. It may be. Okay. Something may be.
Sir, I have a question, sir.
Yes, sure.
Sir, center of gravity and center of mass are two different points of a object.
Okay, I'll tell you. Say this is depending upon the acceleration due to gravity. Okay. So one is multiplied with the center of gravity is multiplied of mass with the acceleration due to gravity. Now when you are considering small object, the way we used to deal with in this earth, okay, everything like you have some object, engineering, some application of the car, maybe your light post, maybe your aircraft components. So this object is small. So variation of acceleration due to gravity is almost zero. It is zero. But when people are working on with some space, some debris in the space, okay, huge structures. In that case, structure, say you are considering Earth itself, then structure is huge, correct? So its center or maybe moon, entire moon. So what we can do, or maybe some other planet. So what we can consider that acceleration due to gravity, it is gravity that may not be uniform. In that case only this center of gravity and center of mass can vary, or else for small object both are same. Got your point?
Understood.
Yeah.
Yes, sir.
Is it clear?
Yes, sir.
Okay, thanks for asking the questions. Okay, so here what I am discussing that given the problem, what is been, you have to be careful what is been asked. If it is been asked calculate center of gravity, then that expression you should start with this. Some numerator and denominator terms may be cancelled out, but you have to start with this expression. If it is center of mass being asked, then use these expressions. Centroid of the volume, use this expression. Centroid of the area, use this expression. Center of the line, use these expressions. Okay. So yes, that is done. That's why W equal to mg, okay. As I told, W I have shown there, weight, W equal to mg, and dW equal to gmg. Okay, maybe I can explain you this way. So centroid, maybe this you told d, sorry, x dw, integration of dw. Now how it is coming then? Then this is x g dm by g tm. This is the expressions. Then g can be cancelled out, or it may come outside of the integration when g is constant. If g is constant, then only we can write this way, correct? X dm dm. If g is constant, so that assumption is there. If g is constant, then only centroid, center of gravity and center of mass will be same, or else it is not, because we cannot. So g is a function of some x. If it is so, g is not uniform for very big shape objects. That is not for the things we are having in the earth. These all are small objects we can consider. Then only that centroid, sorry, center of gravity and center of mass may be different. So when it is center of mass, we will use these expressions. When if somebody is working with some position vector r, then somebody can use these expressions. Now, if I expand dm, rho dv, and rho is say, if it is rho is constant, if it is not constant, then it will be inside. Okay. If it is rho is constant, then rho will be outside. Density. So it is homogeneous. Density. Rho constant, density constant means homogeneous. Homogeneous body. Then your center of mass will be same as the centroid when rho is constant. Center of the volume. Now, as I told, if your say thickness is constant, the same as center of mass. If cross section is constant, same as center of line. Okay. Okay, maybe this question is there. Center of mass versus center of gravity. You can get from the books, textbook, the difference. Now there are some examples. Say this is the location of center of mass. This is the center of mass. Now centroid of line, area and volume. Same way I told, if it is line, what we'll use? We'll use these expressions, and this expression. Maybe one thing I can change this. Maybe you will be confused. Let's give, instead of dx, let it be dl. Because if we do this, total length will calculate. Okay. So instead of dx, we'll use dl. It is, yes, this is the centroid of line. Because what we did, we use this dm equal to rho a dl. Say now rho and a are constant over the length of the rod. Then rho a, this rho a will be numerator and denominator, it will be cancelled out, it is constant, it will come outside of the integrations. So this one. So this is the dl, this is some curved line, and so this is the cross sections. Okay. So this is the cross section, this is the line basically. As this is the line, small strip length dl. So integration of dl will be the total length l. Take first moment x dl. Okay, first moment to get x bar equal to x dl by this. Now you take proper that limit for integration. So we'll come to that type of expression. So this is the x for the small strip. This is the x small strip. This is the y. This is the z, and we have calculated based on x bar. So y bar will be y dl. This is dl. Z bar will be z dl. You have to be careful. We are utilizing first moment. Okay, we are using first moment principle. We are taking first moment. First moment means one type. So this is dl multiplied by x. we call first moment. If it is second moment, x multiplied by x square dl. That will go to the area moment of inertia. We'll talk later, okay? Not now. This is the first moment. Now it is surface. If it is surface, this is the area dA, okay? So x bar, so if it is the area dA, this is the x, this is the y, this is the z, okay? Maybe centroid is this is x bar, this is y bar, this is z bar. Same thing is true, x, y bar, x bar, z bar. So here, x bar will be, it's a dA, correct? dA multiplied by x, first moment of area, okay? Y bar, y dA, dA, z, sorry, z bar, z dA, indication of a dA. Now what form will be this dl or that functions will explain that later, okay? So this dA will be some function of x, y, z, whatever may be, we'll see. dl may be function of x, y, z. Say for example, x square one function, okay? Like x, y, another functions. A different way we can check later. Now when we are talking about area, as I told, this, and this. So we are using first moments of area. Principle is we are using first moment. First moment of either weight, mass, volume, area or line. Using first moment, using from the concept of the moments, we are calculating the centroid of line, area, volume, or maybe center of mass, or maybe center of gravity. Okay, for volume, similar way, we will utilize these expressions. Okay. Now, when you want to do the integrations, so the function that there is some y equal to fx, or y or maybe function of x, function of xy, maybe function of xyz, possible function of xyz, some functions. So we have to choose the element for doing the integration such a way that integration is supposed to be very easy. Integration is supposed to be very easy, preferably first order of the elements is such that we want to do some sort of our choice of the say area is like this: dA equal to L dy. Let me check 5.4. Yes. Here, what is this area? This is the area, correct? Area. So area of strip we can consider here this one. Area of strip here, what is dA? It is, you can see, L dy. It is very simple. L multiplied by dy. Here it is area dA, right side. It is dx dy. Which one is easy to do the integrations? Maybe this is given y equal to fx. Sorry. This is given y equal to fx. Which one is easy for you, left or right?
Left one.
Yes.
Left.
So you have to be, yes. So what you have to do, you have to be very tricky to consider that. This is the correct one. Say for example, here it is volume, correct? So to calculate volume, say dV. Sorry. dV, okay? Here, left side dV. What is dV of this element, area of the strip? It is, you see, pi r square dy, is not it?
Yes, sir.
Pi r square dy. And here it is d, it is x, y, this is z, correct? So dx,
If it
dz.
will be pi r square, then this would be dr, na? There is variation of r.
No. Pi r square is this, pi r square, okay? Then to get volume, dy will be multiplied. Now r will be function of something, that we will do later. Okay. R is function of this cone, okay, right angle cone. R is the function of something, we will do later. But it is pi r square, it is dV basically, okay, volume. Pi r square multiplied by dy, that is enough to calculate the volume. Understood?
Sir.
Here it is dx dy, see dz, dx dz, then dy. Then I want to calculate v equal to say this. So this integrations, this is v. So this is case 1, this is case 2. Which one is easier?
First one.
One.
First one. So
One.
you have to be very tricky to consider the strip or element on which you want to do the integrations. So what we are trying to do, we are trying to make the integrations, make that integration form such a way that it is very simple to do the integrations. Okay, say for these examples, okay, this is area, correct? Area, left and right. So for this case, maybe it is not given. Let me write. This is y. So dx, y dx is the area, is not it? Here, y dx is the area. This is dx. If I write y dx, this is the area, correct, of the strip.
Yes, sir.
Yeah,
Yes, sir.
but
Yes, sir.
somebody can do like this, like this is y dx plus y means based on this point, y dx plus that triangle half dx dy. Somebody can try with this, but this is more complicated, is not it? It is more complicated to calculate. So better if we have this and you know a equal to this, and this maybe this is a so this one x is a 0 to x1. Then you can calculate up to this. You can calculate up to this area you can calculate. Okay. This area you can calculate, but you cannot calculate for this one, for this one, because this one you don't know, is not it? This one you don't know. It is discontinuity. It is the discontinuity of the problems. Instead of that, if somebody can take this horizontal strip, and can do these integrations, whether you will be able to find out the value or not for this one.
Sir, what's the limit for horizontal strips?
Horizontal strip, maybe
X1
some
to
say 0, say this is x1, maybe this is x2. I'm assuming if this is x1, consider this is the x2. Now tell me, if it is so, then what could be the best way to get these solutions?
Horizontal strip. By taking horizontal strip.
You can take horizontal strip and you can go for y value, some this to this.
Yeah, from y1 to y2, or its limiting
No.
value.
Yes. But you are right. What you have to do, you have to be very careful. You consider this strip, horizontal strip is like this. Initially, you consider like this. Okay. Basically, this is x2 minus x. If you consider this one, just a minute, x2 is higher than x2 minus x. If it is x, if it is x2, you try to understand, this is x2. So if I write this x2 minus x2 value is given, some value given, this x2 value is given. So x2 minus x is this, is not it? And x2 minus x, this one x2 minus x multiplied by dy. If we write this x2 minus x multiplied by dy, this is the area. But so in terms of y, we have written in terms of y, but y is varying from 0 to y2. Sorry, just a minute. x1 0 to y2. So are you able to solve this problem that way? You just think of it.
Understood, sir.
So you have to take carefully that what functions you want and then you solve it. Say for example, this is if this is the this is the given one. So what we can do? You can take vertical step. You can take vertical step. Recall or remember, you should consider centroid of the element. What step? Why I am talking about this? So roughly, this is the step, vertical line. This one. Basically, it is having two elemental centroid. We call XC or XE elemental and YE for this element. XC is X and YE is Y by 2. Is not it? If this is X, this is dx, and this is y, then what is that? These locations. If you see this location, xe elemental x centroid, xe y centroid of the element. xe is x, is not it? This one. xe is x and ye is y by 2. Have you understood this one? I'll tell you. So when you want to calculate say x bar, you have to write it is x bar equal to x, this is x, actually x e area, correct, dA multiplied by dA. dA will be y dx and here it will be y dx. Indication point is for this. So what you want to do, it is dx. So x, so then you will write if equal to x equal to ky square. So y equal to square root x by k or 1 by square root k multiplied by square root x. So here it is, we will write x equal to x, y equal to 1 by root k root x dx by y is 1 by root k root x dx. Indication point is say x, say this is a 0 to a 0 to a. If it is a and say consider this is AB, y is B, then it is passing through AB. That means a equal to k multiplied by b squared, k equal to a by b squared. Given the value of this AB, say 5, 7 or something, you can easily calculate the value of k. Once you know the value of k, this is nothing but you have to do the integrations. So this could be the one way to calculate x bar. But when you want to calculate y bar, that is ye y dx, here it is y dx. What is ye? Y is y by 2 multiplied by y dx integrations, here y dx. Now top you will get y square equal to x by k, you can write here. That means y square equal to x by k by 2 half dx, here it is 1 by root k square root x dx 0 to a 0 to a. That way you can calculate that way you can calculate this centroid. Say for example this example, instead of taking that Cartesian coordinate, we can go for polar coordinate. Maybe somebody can do like this.
D theta angle.
Yes. So this is theta, this is d theta, and maybe here you can consider this is the triangle. So this will be, from this to this will be 2/3 of r. This is 1/3 of r. Then you can calculate from this triangular area, you can calculate the centroid. We'll come to that one later. We check. That's why we told this order of element is important. Then continuity. So it should be continuous. If it is the discontinuations, you have to be very careful for doing that one. So we are trying to discard the higher order terms. We have simplified here. We are not considering this approach. So I have coordinate, maybe Cartesian coordinate one I told maximum. Last one I told it is polar coordinate. Sorry. Now centroidal coordinate of the element already I told. So instead of x, we will consider ex here xc, yc, zc. I rather write xe element. Okay, ye, zd. This example is here. Actually, as I told, I am writing xc. It is y. This xc, you can see this xc is, say if it is x2 and this is say x1, then xc is basically x1 plus x2 minus x1 by 2 equal to x1 plus x2 by 2. Is not it? Xc is this, but y equal to directly y, because centroid of the element is here. Similar thing is applicable for this strip also. This xc is, this is x basically. The expression will tell later what is the the location of the centroid for this semicircle. That will do later. So centroidal element over, or volume also we can do. Now let's have some examples. Locate centroid of the circular arc shown in the figure. So in this figure you can see we have circular arc. Circular arc, it is line body or area or volume?
Line body.
Line. Okay. Now when we are doing this centroid of the circular arc, maybe this, for simplicity, we want to take this symmetry. So plus alpha minus alpha. We have considered some symmetry and we are assuming this is the centroid. Yeah, our assumption, this is the centroid. Now, if it is alpha, maximum alpha may be, how much will be maximum alpha to get the circle?
Pi
180.
Pi.
In radian. Yes, we have to be in radian. Okay, pi. So if it is pi, then what will be the length? L max for circular one. What is the length? This is the length.
Pi r.
Pi r.
Or 2 pi r. Length.
2 pi r. Whole length.
This one, the whole length, 2 pi r. Okay, 2 pi r. Okay, that means when is alpha equal to pi, it is 2 pi r. But when alpha equal to pi, it is 2 pi r. Okay, alpha equal to pi means 2 pi r. When alpha equal to alpha, then what will be the value, length for alpha?
Alpha L. 2 alpha L.
Okay,
2 alpha r.
2 alpha r.
2 alpha r. So how we can do this? Alpha pi equal to 2, this 2 pi r, 1 equal to 2 pi, is not it? So alpha equal to 2 pi r. 2 r. I'll tell you here. If it is pi, it is 2 pi r. If it is 1, it is 2 pi r by pi equal to 2r when it is alpha, twice alpha r. That means alpha r. This length basically, arc length is actually 2 alpha r. Okay. This length is 2 alpha r for this case. Now, if it is the centroid is located here, so our usual equation was x bar multiplied by length equal to integration of x dl. This L is 2 alpha r. So we can write this 2 alpha r multiplied by x bar equal to integration x. What we'll write here, our expression was that x dl. That way was our expressions. Okay. So to do so, if we consider this is the alpha, and maybe this is one small theta, d theta, and this is the r. So what is this? S equal to r theta says this length is r d theta. Is not it? This length says r d theta. So in elementary sense, this r d theta is the L, dl actually. So dl equal to r d theta here. Now, what is the distance from here for this r d theta length? That is r cosine theta. You can check it. Okay. For this one, if this is the theta, this is the theta, then for this centroid, what is this distance? You can check it easily. It is r cosine theta. So our equation was like this: x dl. This was the integration basically. X basically here it is r cosine theta. What is dl? R d theta. What is the integration point? Sorry, limit minus alpha to alpha. R is constant, so it is r square. This is cosine theta, correct? R theta. Then it will be sine theta. Is not it? Minus alpha to alpha. Okay, minus alpha to alpha. Now, sine alpha, sine minus alpha both are positive. So, twice r square sine alpha. So, twice r square sine alpha. What is that? That is 2 alpha r x bar. Then what is the x bar? What is the x bar? You divide it by 2 alpha r. 2 will be cancelled out. Okay. 1 r will be cancelled out. Then it is x bar equal to r sine alpha by alpha. That is the expressions. So centroid of this arc is r sine alpha by alpha. Now you consider when alpha equal to pi by 2. When this alpha equal to pi by 2. Alpha equal to pi by 2. That way if I write, that means we are here. If alpha equal to pi by 2, you put here. Then what is the x bar value? Alpha equal to pi by 2?
R by pi.
Okay. If
What by pi?
R upon pi.
Okay. So r upon pi by 2. Is not it?
Yes, sir.
So 2r by pi. That is the reason this distance is, sorry, this is the centroid. This is the centroid. This is twice r by pi. So if I write this way, this is twice r by pi. Now you consider, if you take this symmetry, if you take the symmetry portions also, for this case, or I will give you other exercise. If you use this one, then this way it is this 1/4. Then also this distance will be twice r by pi due to the symmetry, that distance. If you take the symmetry with this is symmetry with this, correct, with vertical axis. So in vertical axis, if you take symmetry, then this vertical distance will be same, but horizontal distance will be different. If you have any doubt what you can do, somebody can do this way also. You can have this here, theta, d theta, the way we did, you can have integration from 0 to theta, and you can get theta equal to 45 90 degree pi by 2. If you put, you can get this semicircle expression also. Now we come to this one, when alpha equal to pi, what is happening then? What is x bar? Alpha equal to pi, then
0.
0.
0.
That's why it is 0. Yes, yes. So we will utilize this expression that locate centroid of a circular arc, and that's you have to recall, if it is circular arc, then it is r sin alpha by alpha. When alpha plus minus alpha you have considered due to the symmetry of the arc, then we can deduce to some other expression, alpha equal to pi by 2, alpha equal to any alpha value we can put, correct? Putting any alpha means actually it is twice alpha. Okay, it is twice alpha, the arc angle at the center. That one we got it. Next one, when we have one triangular shape, we know that centroid of this is, if height is h by 3, we will prove here. Before that, maybe I'll show you simple one. Say I have one rectangle. This is A, this is B. Okay, this is the centroid, is not it? What is the centroid locations? If it is, this is 0, 0. What is the location of the centroid?
A by 2, comma B by 2.
We'll prove that. So if I use the same, why I am telling this? I am just trying to simplify the problem. You will understand. So what we'll do, as this is the 0, 0 point, we'll take one horizontal step. This is y, this is dy. So y bar is ye. I'll write here. This is the ye. Let me have this area, correct? Area is
A into dy.
A into dy. Yes. And this is ye multiplied by A dy. Y is nothing but ye equal to y A dy dy. 0 to B, is not it? 0 to B. Y we are doing, correct? Okay, something I missed, A. Okay, A will be cancelled out. See, this is y square by 2, 0 to B, y 0 to B. Okay, so it is B square by 2 by B equal to B by 2. Actually, from where we got actually y bar equal to B by 2. Now, how we can get x bar? Tell me. To calculate x bar?
Vertical strip.
Exactly, very good. So we have to take vertical strip. Remaining thing you know what you have to do. So that is the simplest way we can tell that yes, we have very simple geometry. Yes, x by a by 2, b by 2, whatever we got. This is basically output from this first moment principle. Basically, this has been drawn from the first moment principle, this centroid, even for simple rectangular geometry also. Okay, this exercise is not for exam, to build your confidence from where we have started basically. Now you come to here, we will show that from this, the centroid will be located at h by 3. Okay, to do so, first of all, we have taken horizontal strip. And dA, what is dA value? What is the dA value of this?
dx.
X dy.
X dy. Exactly, X dy. Okay. Now what is X? We can get from that similarity triangle. We have two triangle here. Maybe it is very small, dy is very small. So we can consider that this centroid is and this upper and lower portion, those are same. Two triangle you can see. So it is basically x by b equal to h minus y by h. This by this equal to this length by total length. So this is the expressions we have. In that case,
Yes, sir.
this dA is x. Will replace this x by that word b by h minus y dy. This is the dA. So if I write that is the dA, so our expression is that a y bar equal to ye dA. Okay. What is ye here? What is ye for this step?
Y.
Exactly. So y b by h minus y dy. And this is, if somebody can do these integrations directly, you can get half bh. Is not it? So this multiplied by this equal to this expressions. It is very simple. You have to do integrations. Limit is dy. We have considered dy. If it is dy 0 to h, so that is this. If it is so, then y bar equal to h by 3. So what we did, we are using first moment expressions to calculate centroid of the triangle from the base. Okay, and we can show that from the base the distance is h by 3. Now if somebody want to take this as the base, this is the base, and so this is the geometry, and you know the height, say h1 h prime. This base you can calculate, this h bar h double prime you can calculate. Basically what is happening, this 3 case, if you consider that is the centroid, okay, that is the location of the centroid, using all these 3, that is the actually intersections of the medians. That way you can calculate, that is nothing but intersection of the 3 different medians. You draw this okay. If you are doing correctly, then this intersection will be okay. I am a little wrong maybe, so you do accordingly and you will calculate that the centroid of that triangular of the triangle, okay, based on the area. Now till now what we have did 2 cases we have solved only. One is circular arc, alpha plus minus alpha, and we have shown that it was centroid was xc was r sin alpha by alpha. Now what we want to do, centroid of the area of a circular circular sector. Okay, actually it is 360-degree sector, means full, okay, circular sector, and we are considering this is the area. Okay, now when we are considering area, similar way, if it is 2 pi, this is alpha, sorry, I write this way. If alpha equal to pi, when alpha equal to pi, then it is full area. What is the area? Pi r square. Alpha equal to 1, then pi r square by pi. Alpha equal to alpha is alpha r square, is not it? Area alpha r square. This sector area is alpha r square. You can check alpha, you put alpha equal to pi, it is pi r square, full one. This is the area alpha r square. That means basically A is alpha r square. This is the area. Have you understood this? Yes or no?
Yes, sir.
Yes, sir.
This is the area. Now what we have to do, this xc multiplied with this A equal to indication of x dA. Okay. Now we can have different way of doing this. Maybe I'll go for the second method. In second method, we have this is alpha. This is sorry theta. This angle is t theta. So this base is, this is basically r. Radius is r. So this length s equal to r theta will give. Sorry, directly I can write s equal to r d theta. This small strip, triangular shape. It is a triangle. Okay. You consider this strip. What is the area dA of this strip? Half base r d theta multiplied by height. Height is r.
Yes, sir.
So half r square d theta. dA is half r square d theta. Okay. Now then if I want to write here x, what is the x of this strip? It is from the base 1/3. Is not it? We told that if it is circular one, for triangular one, if I have this one, from the base it is 1/3. So it is r by 3 from the base here. This to this r by 3. Is not it? So this to this distance, twice r by 3. 1 minute. This one, twice r by 3. Have you understood this point? We told that for one triangle from the base it is, if it is r by 3, then this to this distance is 2r by 3. Have you understood? This to
Yes,
this
sir.
distance, 2r by 3. Then what is the component along the x-axis? 2r by 3 multiplied by cosine theta. Clear? X is 2 by 3 r multiplied by cosine theta. So in expression what we want to write? A x bar equal to minus alpha to alpha 2 by 3 r cosine theta multiplied by area half r square d theta. What is A? A is alpha r square. So alpha r square multiplied by x bar. What is actually this xc? Here it is xc. I rather write xe, elemental. So r square alpha x bar equal to minus r alpha to alpha. This is basically xe multiplied by a dA. Then this is the expressions. R square alpha x bar equal to 2 by 3 r cube sine alpha. X bar equal to 2 by 3 r sine alpha by alpha. I'll write here. This is for line or arc. This is for sector. Xc equal to at xc1 say 2 by 3 r sine alpha by alpha. It is similar, is not it? Only 2 by 3 has been added, multiplied, and that contribution of the 2 by 3 is nothing but from the circle. Once again I want to tell, whatever you got the centroid for arc, it is similar pattern for sector. it is r sine alpha by alpha. For this line or arc, it was nothing but centroid, elemental centroid was lying on the line itself. That's why multiplication factor, if it is lambda equals here lambda equal to 1 and here lambda equal to 2/3. When it is arc line, centroid of the elements is lying on the line itself, that's why lambda equal to 1. When we are using some sector area, then in elemental strip we can have some triangular shape, and from the triangular shape, centroid of the triangular shape will give one contribution 2/3. Or in other way, you can consider this very simple way. If you have this is the structures only line, and other one is this is the structures with solid one. This is the only line. Okay. Then there is no material here. Okay. So no contribution for that. But here there is some material. It will try to keep it back, the centroid towards the center. That's why here it is 2/3. It is 1. Have you understood this point? Or should I explain once? Need your input?
Sir, please explain one.
Yes. First of all, for arc, centroid of the arc is r sine alpha by alpha. That you understood?
Yes, sir.
Okay. Now, instead of arc, we have one area. We have one. This is the area. We have to sector. We have to calculate the centroid locations. So what we did, we have considered one small strip, and that strip is in the form of triangle. So triangle area we know half multiplied by height r multiplied by base s equal to r theta. Theta is in radian. S equal to r theta. When this angle is theta, this is d theta. R d theta is the s. So area we can get half into base r d theta multiplied by height. So this is the dA. Somebody can do the integrations, minus alpha to alpha, or directly we can get it is alpha r square. That is the area. Now to calculate the CG locations, our expression is x bar a multiplied by x bar equal to xe elemental x. Xe elemental x multiplied by dA. What is elemental x? This is the element. Elemental xe is how much? If this is total distance is r, the centroid is here. So this distance is twice r by theta, because it is triangular shape. If this to this distance is r, this is twice r by theta. Take the component. If this is the theta, this is 2r by 3 cosine theta. That is xe elemental x. So I'll write here 2r by theta cosine theta. dA equal to, I'll write pi r square d theta. Integration minus alpha to alpha plus alpha. And if we do the integrations, we'll get this expression. Sorry, we'll get, yes, left side was r square alpha multiplied by x bar equal to 2/3 r cube sine alpha, or x bar equal to 2/3 r sine alpha by alpha. R sine alpha by alpha is similar to that case for arc line. Now we are dealing with area. Similar, but there here if I consider this is one factor lambda equal to 2/3, but for the arc it is lambda equal to 1. Why this difference? Because you can consider that as this 2/3 terms has come from this, the elemental strip of the triangular shape. From there, when we have converted to get xe elemental length moment arm, that was 2/3 cosine theta. Cosine theta has been used for doing the integration, but this 2 by 3 terms is remaining there. 2/3 is the distributions for some masses present for the sector. So when it is only line, the elemental centroid is here itself. Okay, but when it is this is the area, then we have considered some triangle, and here 2/3 of the radius was the elemental xe coordinate with some value xe 2 by 3 r 2 by 3rd. This is the contribution here. Have you understood now? Is it clear?
Sir, yes, sir. But
Yeah.
yes, sir. But in the exam, we have to explain or write all the things that you have write.
Okay, I'll tell you. If I ask calculate the centroid of the arc and sector and give the comparison, then only we'll write this. Or else you know the expression r sin alpha by alpha. Okay, lambda r sin alpha by alpha. Lambda equal to 1 for arc line. Lambda equal to 2 by 3 for area. That's all. Okay. If it is not been asked, you don't need to prove this. But if you prove 2-3 times, you will get confidence, because that will be utilized many times. Okay, let's see this alpha equal to pi by 2. Then x bar equal to this one, equal to alpha equal to pi by 2. So 2 by 3 r 1 pi by 2. Okay, so equal to 4 pi
4r by
4r.
3.
Yes, 4r by 3 pi. Now question is, if I ask in the exam to do this, you got some alpha equal to pi by 2. Alpha equal to pi by 2 means half sections, correct? Half sections. Then what you can utilize, that you know the expression x equal to lambda r sin alpha by alpha. Okay, lambda equal to 2 by 3. Taking alpha equal to pi by 2, you are getting this. That is enough for me. Rather directly writing to x bar equal to 4r by 3 pi, it is better to write x bar equal to 2 by 3 r sin alpha by alpha. Now you are putting alpha equal to pi by 2, and you are getting x bar equal to 4r by 3 pi. That enough information is enough for me, because you are solving some difficult problems. So this will be very simplified one. Understood?
Yes, sir.
Another way we can do, that is, somebody can consider that this is the small strip. Okay, this is the small strip, and for this small strip, area dA equal to twice r0 alpha dr0. Why? 2 pi r dr. 2 pi r dr was our main expressions. 2 pi r multiplied by dr. If it is complete, we supposed to use 2 pi r then dr. Now here this pi becomes alpha, is not it? Pi becomes alpha. That's why 2, here it is r0 we have considered, dr0 we have considered, 2 r0 alpha dr. That is the area, multiplied by this dA multiplied by r. Okay, dA multiplied by r. If I use that one, then we can get that that moment. So to do so, we will use these expressions: a x bar xc. This, what is a bar? Sorry, a, that is alpha r square x bar. Then right side. Right side is 2 r0 pi dr. 2 r0 pi dr0. That is the dA, and multiplied by its its distance of the element. Distance of we call that is xe. Rather say xe. And this is the strip. This is the strip, very thin strip. We can consider this is the line only. Then we can write that is nothing but r sin alpha by alpha. And this is the r sin alpha by alpha. Indication is 0 to r, because we have considered r0, dr0, 0 to r. That way also you can solve this same problem. So what we can do is, in other approach, we can take r0, dr0, then we have small strip. Area of the strip was twice r0 pi, alpha multiplied by dr0. Then the strip was on very thin strip, can be considered as the line arc, and centroid of that element was r0 sin alpha by alpha. And if we equate that expressions with this, then we can get similar expression. Now in exam, if it is been asked either of the way, you can solve the problem. I have no issue. Okay. Can I move to the next? Is it clear?
Yes, sir.
Yes, I have very less time. I have 25 minutes only. Okay. I'm moving fast. Okay. Next, locate the centroid of the area. Locate the centroid of the area under the curve x equal to k y cube, from x equal to 0 to x equal to a. X equal to 0 to x equal to a. So we have to consider centroid. Somebody can take horizontal strip, somebody can take vertical strip. Here vertical strip has been taken. Why vertical strip has been taken? Can anybody tell me reason behind that? Okay.
Sir, x is a function of y.
Okay.
So, sir, those centroid is located at y by 2. So, we can do dA equals to x dy.
Yes.
Oh.
No.
Because we know limit in x na a up to a.
Okay. Okay, fine. So as you told, here if I take this vertical strip, yc, you understood. I used to write ye elemental. Okay, ye equal to y by 2. You understood. Now and xe equal to x. That also you understood. Now what is dA? dA was y dx. Is not it? This is dx. Y multiplied by dx is dA. Y, this is the d. Okay. Now y is x by x by k power 1 by 3. Okay. Before that, as it is passing through AB point, is not it? This is AB point. You see, this is AB point. So you can write when x equal to a, then k y equal to b. Then k equal to basically a by b cube. Is not it? K equal to a by b cube. That value you know. K value. Now, if it is dA equal to y dx, so we can write, simplify this, that x bar multiplied by a equal to integration of x e y dx equal to x equal to x, y equal to x by k power 1/3 dx. Integration limit is 0 to a. Okay, 0 to a. So somebody can utilize this, and you can get the solution of x bar as this. Okay, it is up to you how you will be doing this integration. For y bar, y bar multiplied by a equal to y dA, y basically y by 2. Again same, dA equal to where I have written, yes, y dx. So half y square dx. Half y means x by k, so 2/3 dx, and 0 to a. You can do and you can get the value. Once you will solve, you will get the correct results. Okay, this is up to you. Integration will take some time. Be careful. So you will get this. Another solutions, as I told, somebody can consider horizontal step also. So what you have to be careful in horizontal one, that xc or xc will be a plus, here it is x, it is a, so it is x, it is a minus x, and this centroid xe equal to a plus x by 2, and x equal to ky q. Okay, so for that one, you can write this way then, x bar multiplied by a equal to xe dA. What is xe? That is a plus x by 2 multiplied by dA, I think y dx, correct? Now y, you can convert to y equal to, I think, x by k power 1/3. Integration point is 0 to a. Same results you will get, but you can see here it is more complicated, is not it? Function is more complicated if you take this one. That's why you are correct. Taking vertical step is easy to do the integrations. So that is the way you have to be careful whether you will take horizontal step or vertical steps to save time. Okay. Once you are working this, you will be expert in that. Don't worry. Next is, say you have to locate the centroid. You have to look at the centroid of the volume of the hemisphere with radius r. So for doing this, it is taken from book example, you can check it. So this cube is basically y square plus z square equal to r square. This is z, this is y, this is x. And if you take this strip, for dv equal to this distance, basically this distance is nothing but this distance square equal to r square minus y square multiplied by pi. Okay, this, so pi r square multiplied by dy, that is the volume. Okay, once you will get the volume, you work on that, do the integration correctly, you will get y bar equal to 3 by 8 r, y bar, this to this will be 3 by 8 r. Next is, say I have one composite bodies. I have different composite, I can simplify this. Okay, maybe this is one hole, this is aluminum, this is steel, and this is steel, aluminum, and this may be copper. Different material density are different. Okay, density are different. If density is different, so mass will be different. So for those case, to calculate those type of composite one, we will use Varignon's principle. What is that? Using this is the all summation of the different forces multiplied by x bar, centroid of the entire body, is nothing but individual summation of the moment of the mass with respect to principle, respect to some axis through which we are calculating. So it is using, we are using the Varignon's principle. Then summation, all summation of masses multiplied by the center of the entire body is nothing but summation of the individual masses and corresponding the centroid locations. If you use this is nothing but summation m. This is summation m. This we used to write summation m x bar. So that way, x bar equal to this, y bar equal to this, z bar equal to this. If it is weight, then we used to write here mg. Here it is mg. It is volume, then we should write this way, summation of v x bar by summation of v. If it is area, summation of a x bar, summation of a. If it is line, summation of l x bar, summation of l. It will be followed like this. Whether it is weight, centroid, center of gravity, center of mass, center of the volume, center of the area, center of the lines. Say this is the examples for this. Now, similar way, we have same expression we are utilizing here is also so. So let's have some examples. Say I have these structures, very simplified structures. So you can see this is one cutout, this is one cutout. So what we can do? We can consider first this entire area, this area we can consider first. Okay, entire area minus this, then we'll get these portions. Minus this cutout, okay, this is cutout, minus this, plus this. So we have 1, 2, plus, both are plus, this is minus, 3, minus 4. So this is the composite structures. We want to calculate the centroid of the shaded area. What we are going to do? We have split it into 4. After splitting into 4, 1 positive, 2 positive, 3 area is negative, 4 area is negative. We want part 1, 2, 3, 4. What is the area? First one is this, second one is this, third one is negative, fourth one is negative. What is the x bar? You know, for this x bar, this distance by 2, x bar. For all cases, you can calculate x bar, y bar. Then what is x bar a? This. What is y bar a? This. What are the summations? Summation a is this. Summation x bar a is this. Summation y bar a is this. Then x bar equal to summation a small x bar by summation a, that is this. Y bar is this, summation this divided by summation a this. Next, so I have this much of complicated one geometry. So I can split it into 1, 2, 3, 4, 5. Out of this, only this is minus. This is minus. Then if I use this 1, 2, 3, 4, 5, this is the mass, this is negative, y bar, z bar, my bar, mz bar, y bar, z bar. Okay. Now theorem of Purpose. In theorem of Purpose, it is told that when we want to rotate any length with respect to some axis, length, then we will get area. When we will rotate some area with respect to some axis, we will get volume. Okay. That expression will be used in theorem of Purpose. It says that if we have length, total length is L, this is the DL length I am talking about, and we have some rotations by 2 pi, then total area will be 2 pi integrations y dl. Okay, integration y dl. Once again, this y dl is nothing but y bar L. We have learned before. Integration y dl is nothing but y bar L, then this y bar L equal to integration y dl. Due to this relationship, then this A equal to 2 pi y bar L, or volume equal to 2 pi say y bar A, or somebody can write M equal to 2 pi y bar, here we can write rho A that way, or weight also rho G, that expression we can use. Here why it is pi can be alpha also. If pi equal to 2 pi, if alpha equal to 2 pi, then it is complete rotations. So we'll utilize this, B equal to this. Okay. Now same expressions, B for A, for B, length also we can do. Now say for examples, we have to calculate the volume of the surface area A, of the complete torus circular sections. So this is given. So this is your cross sections. This is the cross section. What will be the volume generated? Volume equal to theta r bar A. What is r bar? Basically here it is r. It is given. What is A? Cross section of this pi square. Okay. Complete rotations, it is 2 pi. Then you will get this value equal to 2 pi square r square A square. Then what will be the your area, surface area for this case? To get the surface area A equal to theta r bar L. So theta r prime is nothing but r L. What is the L? 2 pi A. Then we will get 4 pi square R A. This is the surface area of the torus. Now, if I could have this type of cross sections, what will be the value of the volume generated when it is rotated by 180 degree? Alpha equal to pi. Okay, alpha equal to pi. So what we will do? We will take these sections. We will take these sections. Then this is the cross section we want to revolve. We want to revolve by pi equal to alpha equal to pi. So what is this area for this? Half into base into height. Half into base into height. Then what is the expression? B equal to theta r bar A. Theta equal to here pi. What is r bar? Because this is already 30. This is already 30 plus 1/3. This is the triangle 1/3 of the 60. So 20, it is 50. So it is 50 multiplied by what is A? Half 60 multiplied by 60. So you can calculate from this expression total volume. Okay, total whatever the total volume you can calculate. 1/3. Okay, so you can calculate the total volume. Then what is the mass of the body? You have to calculate with the density. Okay, density constant constructed with the steel. Okay, for steel density you can use 7830 kg per millimeter cube. That's all. Any question? So I'll before that I will tell you. So now your task is you have to start working on problem sheet 5.1, 5.2, 5.3. Do you have any questions regarding the slide? We can discuss. We have 8 minutes more. Yeah. Tell me, any doubt do you have? Hello?
Sir, I have doubt from previous assignment.
Okay, that will come. That will come. I'll come. First of all, this. Do you have any doubt after this? I will come that point. Okay. No doubt up to this. Okay, fine. Now another question. As the exam will start from February 14, correct? Do you want to attend the class on 11th February for this mechanics subject? Yes or no? Because your exam will start from 14. It is your wish. I have no problem. If you want to come, I will take the class, or else let it be holiday for that day from my side for your preparation.
Sir, give us a time for prepare us.
Okay,
Yes,
so
sir.
11th, there will be no class on 11th, correct?
Yes, sir.
No problem.
Yes, sir.
Then,
Thank you, sir.
yes, that is true.
Okay, sir. Thank you.
Yes, welcome. So we have then 2 days only. 4th, this Friday, 4th February and 8th February. Okay, and you have only 2 days. And now let me check how many problems you are having. And now I'll come to that questions you asked. So frame, take it frame, then distributed forces. Okay, for distributed forces, we have some simple geometries. You can check it. You can use the theory you already know. For this type of problem, you have to do the integrations. Yes, this I think 10 problems. Then for composite bodies, you can split into different parts. You can solve this. There are 6 problems. And this is theorem of Purpose. You have to take only cross sections, and you have to do the right thing to calculate that that say total mass or volume, whatever you want. It is been asked. So 6 plus 6, 12 plus 20, 12 plus 10. Sorry, 12 plus 10. 22 problems here. Okay. And then this is the problems from the frame. Yes, somebody told to ask. Want to ask any questions from the frame. Yes, carry on.
9.
Problem
9.
9. Okay. problem 9. So what is told that the figure shows a wheel, that wheel is this. Okay, this is the wheel, which is removing a V-belt pulley. Just a minute. Figure shows a wheel puller. Which one? Okay, shows a wheel puller. Okay, which is removing a V-belt pulley P from its tight fitting shaft S. Yes, S I can see. By tightening the center screw. If the pulley starts to slide off, okay, if the pulley starts to slide off the shaft when the compression in the screw was reached 1.2 kilonewton. So compression in the screw is 1.2 kilonewton. Calculate the magnitude of the force supported by each jaw. Each jaw A. Acha. The adjusting screw D, which is D, yes, that supports the horizontal force and keep the slides arm parallel with the central screw. Okay. Are you able to see any two force member here? Is there any two force member?
Sir, two.
Yeah, which one?
Sir,
Connected
to
from
C.
C.
Yes,
C.
sir.
C and B, correct?
Yes, sir.
Yes, sir.
And similarly, this side also. Yes, this side also. Okay, directly I can show you the solutions because time is not there. So this is solution frame. Just a minute. Okay. So you are right. We have this member and this member are two force member. Okay. So basically, where I see from here, I can close this. Yes. So BC, and if I write this is C prime, B prime, okay. These are two force member. So these are two force member. BC, okay. So this is B, this is C, C prime, B prime. These are the two force member. That means force is acting along the line of action, so along the axis. So if it is so, then this is the BC and this is the BC. This is the symmetric. This problem is symmetric. Loading is symmetric, geometry is symmetric. So we can consider force here, it is BC, this side, this also BC, and let's consider it as tension. So when I am drawing this free body diagram, then this will be BC, this is BC, some force here, compressive. Let's consider compressive. And for the given conditions, 1.2 kilonewton load, it has been told. It is coming from the reaction from the lower one. So if you consider that equilibrium equations, I am giving hints only, okay? That this is X, this is Y, summation Fy0. Summation Fy0, then minus 2BC sine 45 degree. It is given 45 degree. From where I got 45 degree, this is 60 degree, this is 60 degree, okay? This is 60, 60, this is 90, so it is 45, 45. So it is 45 degree angle given. So minus 2 BC sine 45 degree plus 1.2 equal to 0. So BC equal to 0.849 kilonewton. We got BC here. Okay, this is BC. Now you come to this one, side one. Okay. This is the last problem. I think it will take only 5 minutes to maximum. Okay. So for doing so, this is RD, this is BC, 45 degrees, 60 degree, 90 degree. This is point A, AX and AY. If I take moment with respect to A, then RD can be calculated. So RD multiplied by 60 plus 90, 150 is the moment term, minus RD was this RD, or I do write this, RD is negative here, I can use this expression. RD is negative, this is positive, this is positive. RD is negative clockwise. BC cosine 45 degree, cosine 45 degree multiplied by 60, sorry, 90. I'm taking moment with respect to this. Cosine 45 degree multiplied by 90, 90 plus BC sine 45 degree multiplied by 15, this distance multiplied by 15. So this will create RD is clockwise, BC is anti-clockwise, BCX is anti-clockwise, BCY is anti-clockwise. Okay. So what I did, instead of BC, I have taken those two components. Or somebody can calculate this perpendicular distance and directly can solve. Then RD can be calculated. Once you know the RD, summation Fy will give AY value, summation Fx will give AX value. So finally, we will get A as square root AX squared plus AY square. So this is AX, this is the AY. I do prefer, as I told, you consider some angle theta, tan theta equal to this AX by AY, the theta equal to tan inverse this value. And you can, whatever value you can write that. Okay, degree. Is it done? Have you understood, or should I explain once?
Understood, sir.
Yeah. So I can stop here. Yeah, I can stop here. So next, see, today whatever I have given, not as the assignment, okay, study material, problem sheet 5.123. You start working that, you will get the opportunity to discuss only for 2 days. Only 2 days you will get. One is Friday, another is 8. After 8, I am not available. Understood? So be serious, start solving that. Whatever doubt you have, next day I will explain. Okay, guys.
Sir,
Yeah.
sir,
Yes.
can you take my attendance? Actually, I joined, sir.
Yeah, sure. Just a
3:42,
minute.
sir.
Wait. Your name?
Sir, CAB 080, sir.
1 minute. Once again, you tell me.
Sir, CEB 080, sir. Sudeep Chaudhary.
Civil, correct?
Yes, sir.
Civil, at the end, what you told?
Sir, CEB 080, sir.
80. Okay,
Sir, 80.
Sudeep Chaudhary.
Sir, me too. Mechanical 52.
Just a minute, mechanical 52.
Sir, please
1
check the
minute.
chat box, sir. I think here a student had wrote that due to mic problem, he was unable to give attendance.
Okay, can you tell me the name of the student?
Sir, please check the chat box. Here, check.
Okay, just a minute. 40 electronics 42, correct? Just a minute. Electronics 42. Yes, I have given 42.
Sir, mechanical 52 is
55.
done.
Just a minute.
52.
55 given, 52 given. Okay, MNB 26. Yes, given. Vicky, correct? Yes, given. Then 55 mechanical, ME 55. Soini given. Then 70. CSB 70. CSB. Just a minute. Yes. Tell me. Given. Yeah.
Yes. MEB 051. Actually, in the last class, I have joined 10 minutes later, sir.
Okay,
I have given a
mechanical 51, correct?
sir.
See, you should tell this way, mechanical 51, 52 that way. ETB sometimes difficult. Tell your department, electronics, okay? 51, correct?
Mechanical 51.
51. Name?
Harshavardhan, sir.
Harshavardhan, yes. Given. Okay, fine. Okay, see you next day. You work hard, only 2 days, 4 hours I am available. Okay, be careful and solve the problem accordingly. Okay, see you on on the next day. Bye.
Thank you, sir.
Okay, bye.
Thank you, sir.
Bye.